Hello students, we are solving numerical examples in projectile motion. So let us see the statement. A milk is poured into a glass of height 140 millimeters and the inside diameter is 66 millimeters. If the initial velocity of the milk is 1.2 meters per second at an angle of 40 degrees with the horizontal, determine the range of values of height h for which the milk will enter the glass. Refer figure. See, the milk is coming from this glass from point A and it is entering into the glass which is kept on the ground. And the initial velocity of the milk is given 1.2 meters per second and it is 40 degrees with respect to horizontal. But see, this 40 degrees is below horizontal. And the diameter of this glass is 66 millimeters. Now you have to find out the range of values of this height h for which this milk is going to enter into the glass. So for that, if the milk falls anywhere between B and C, it will enter the glass, right? So first you consider motion of the milk from point A to B. Find out h. Now you consider motion of the milk from A to C. Again find out h. So you are going to get two values which will give you the range. The range of values of h for which the milk will enter the glass. Understood? So first considering motion of milk from A to B. Motion of milk from A to B. Now tell me all the values when I am saying from A to B. A is the initial position, B is the final position. So what is the horizontal displacement x from A to B? It is 80 millimeters. 80 millimeters. That is 0.08 meters. And what is the vertical displacement from A to B? The vertical displacement. So it is downwards. So it is minus. So from A to B, total it is h minus 140, right? So it is h minus 140 millimeters, 0.14 meters. But being it is downward displacement, you should consider it as negative. Initial velocity 1.2 meters per second. Angle of projection alpha is 40 degrees with horizontal, but it is below horizontal. So it is to be taken as minus 40 degrees. If the angle of projection is above horizontal, it should be taken as positive value. Okay. Now we have the projectile equation. That is y is equal to x tan alpha minus gx square upon 2u square cos square alpha. So putting the values here, you have minus of h minus 0.14 is equal to x is 0.08, right, into tan alpha, that is minus 40, tan of minus 40 minus 9.81 into x square, that is 0.08 square upon 2u square, 1.2 square into cos square minus 40. So solving this equation, you get h is equal to 0.244 2 meters. So that is 244.2 millimeters. So when h is equal to 244.2 millimeters, the milk will fall at B, means it will enter inside the glass at B. Now consider motion of milk from A to C. So motion of milk from point A to C. Tell me the values. Now x is equal to horizontal displacement from A to C. So it is 80 plus 66. 146 millimeters. 0.146 meters. Y is the vertical displacement from A to C. It is h minus 140. So that is h minus 0.14. But it is negative downward displacement. U is same 1.2 meters per second. Alpha is also same minus 40 degrees. Again, putting these values in the projectile equation, you will get h is equal to 386.65 millimeters. Now we have two values of h. So what is the range of values of h for which the milk will enter the glass? So it is 244.2 less than or equal to h less than or equal to 386.65 millimeters. So this is the final answer. From first principles also you can solve this. Being you know the horizontal displacement, first you consider horizontal motion, find out the time, and then you consider vertical motion. Is it clear? Thank you. So we will see one more example. Read the statement. During a race, the bike was observed to leap up off the small hill at A at an angle of 60 degrees with the horizontal as shown in figure. If the point of landing is 6 meters away, determine the approximate speed at which the bike was traveling just before it left the ground. So the bike was moving along this hill and the bike was left the ground at point A and then it is landing at point B, which is 6 meters away. Here the points A and B are on the same plane. The elevations of A and B are same. So it is a horizontal plane. Projectile on horizontal plane. So here you have to find out the velocity with which the bike was left the ground. So we know that range on horizontal plane, that is r is equal to u square upon g sine 2 alpha. So what is r? Is the range, distance between points A and B. So 6 is equal to u square upon 9.81 into sine 2 alpha. Here alpha is equal to 60 degrees. So it is sine 120. So solving this, you get u is equal to, that is the velocity of bike, 8.24 meters per second. So directly using the formula for projectile range on the horizontal plane, so you can get the required value. Or otherwise consider horizontal motion, vertical motion, from first principles also you can find out. Is it clear? Thank you.